Hello everyone. Let us continue the session of linear integrated circuits and digital electronics. Today in this session, we will see standard forms for Boolean algebra. There are two standard forms for Boolean algebra. One is sum of products. Sum of products, commonly called as SOP for sum of products. And the other one is product of sums. Product of sums. Or we can call it as POS realization. POS form, we can tell it as POS form. So sum of products means, for example, sum of products. Some variables are there. This is an example for sum of products. Sum of products of two variables A and B. So this is an example of SOP for A and B. Variables are A and B. Either these variables can be called as variables itself, or it can be also called as domain. Domain of a function, we can call it as domain of a function. So sum of products. This is an example for sum of products. Similarly, for product of sums, we can write product of sums. A plus B plus C into A bar plus B bar. This is an example for product of sums. So here the domain, here the variables are, the domain is A, B, C are the domain of this particular form. Now we will draw a truth table for an SOP function. So a given SOP function A bar, B bar, C bar plus A bar, B, C plus A, B, C. There are three variables here, A, B, C. So we can actually write the function of A, B, C. Function of A, B, C. I have used capital letters here. Okay. In SOP, we know that in digital electronics we can either take 0 or 1. We can take 0 or 1. A variables, the variables will be taking 1 as its value. Variables. So what are the variables used here? A, B, C are the variables. If I write A, we have to assign a value 1 there. B means 1. C means again 1. For variables, we assign 1 as its value. If it is complement, A bar, B bar, C bar, the value assigned will be its complement. What is the complement of 1? It will be 0. What is the complement of B? That is B bar. B bar is 0 and C bar is 0. If so, this expression, the above expression can be written as its binary form. So A bar, B bar, C, everything is complement. So we can write 0, 0, 0, 0, 0, 0. The next term will be A bar, it is 0. B will be taking the value 1. C will be taking the value 1. And A, B, C means 1, 1, 1. A, B, C means 1, 1, 1. So now let us draw the truth table for. So now let us draw the truth table for the given expression. So there are three variables A, B and C. In the question, A, B and C are the three variables. So number of combinations possible 2 power 3. So 8 combinations are possible. A can take either 0 or 1. Similarly, B can also take either 0 or 1 and C can also take either 0 or 1. So if you are drawing the truth table for 8 combinations, A, B and C. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. These are the 8 combinations possible if 3 variables, or we can even say 3 bits. The variables corresponds to corresponding bit. Now, what will 0, 0 represent decimal? In decimal representation will be 0. 0, 0, 1 means 1. 0, 1, 0 means 2. Similarly, 3, 4, 5, 6 and 7. Now what we have to do is, for finding the truth table for wherever the expression is there, that is A bar, B bar, C bar is there, we have to write the result as 1. Okay, so A bar, B bar means this is A bar, B bar, right? 0, 0, 0. 0, 0, 0 indicates A bar, B bar and C bar. There we have to write the result as 1. There we have to write the result as 1. Similarly, next is 0, 1, 1. 0, 1 in the sense 0, 1, 1. It is 3. There we write 1. Again the result is 1. And last one is 1, 1, 1. 1, 1, 1, 1. Result is 1. The remaining values will be 0. The remaining values will be 0. And this is the function output for an SOP expression. So wherever for the corresponding expression, for example A bar, B bar, C bar, for the corresponding expression, the result value will be 1. So if an expression is given to us, we have to find the corresponding binary number such a way that the variable is assigned as 1 and its complement is assigned as 0. Then we will find the corresponding binary values and then we will draw the truth table depending upon the given variables, and wherever the expression is there, we will be putting 1 as the result. And this is a truth table for finding for the corresponding SOP function. So we have seen SOP expression. How to write the expression for SOP? We have seen A bar, B bar, C bar plus, this is just an example, okay, A bar, BC plus ABC, one of the expression, SOP. And now we understood in truth table, from truth table we can write its function. So function of, how many variables we are using in this particular expression? 3 variables we are using, A, B and C. Now the summation, the sum of products, the sum of which all decimal numbers we are getting output as 1. For 0 we are getting output as 1, for 3 we got as 1 and 7 also we got it as 1. So we can write it as 0, 3, 7. So the function of A, B, C equal to summation. If you write summation, that means we have to find the minterms of this particular value. And for that minterms we write small m. Small m means minterms. Minterms means this is the minterm. Each term is called as minterm of the function. Okay, let us take an example. Another example, I will take A, B, C and given summation m of 1, 2, 1, 2, 3. Let me write 1, 2, 3. Okay, 3 variables are given. So again, I'll change here. How we can change this particular truth table? For 1, the output has to be, for decimal number 1, the output has to be 1. For decimal number 2, the output will be 1. And for decimal number 3, the output will be 1. Remaining, it will be 0. So this is the corresponding truth table for this particular function. If it is given as minterm, small m, that means the result has to be 1 there. Now, how we can write POS expression? We have written one POS expression. Let me write one POS expression. A, B plus C into A bar, B bar, and C bar. Okay, I have written an expression. A plus B plus C into A bar plus B bar plus C bar. Now let us see a POS expression. For example, let me give A plus B plus C and A plus B bar plus C. Okay, here in the case of SOP, we have assigned 1 to variables and variables complement, that is A bar complement will be 0. Here it will be vice versa. The variables will be assigned. Here A, B, C are the variables. It will be assigned the value of 0 and its complement will be correspondingly getting the value as 1. So if so, what will be the value for this one? A, B, C. It will be 0, 0, 0, corresponding binary number. And for the next one will be A will be 0, B bar means 1 and C will be 0. So what will be the decimal numbers for that? This will be 0 and this will be 2 for us. Okay, so A plus B plus C, we are having 3 variables here. In POS expression, each variable will be assigned the value 0. So its complement of the variables will be getting one as its value. Now, I am going to represent the expression in terms of its binary number. A, B, C will be 0, 0, 0 and the corresponding decimal number will be 0 and 2. Now, in the truth table, what we are going to do means, wherever we are having 0 and 2, that are the two expressions given the question. So, 0 and 2. For 0 and 2, the function's output will be 0 here. 0 here. 0 here. In the case of SOP, it was 1. In the case of POS, it will be 0. It will be 0. Remaining terms will be 1 in this case. Remaining terms will be 1 in this case. So, this truth table is corresponding to POS function A plus B plus C into A plus B bar plus C. So we will write in terms of its, like we have written SOP in terms of its min terms, we will write POS in terms of its function. So function of, how many variables we have used? A, B and C. In the expression we have used only A, B and C, the function of the variables. Okay. Sometimes they are using a capital F also for function. In some textbook it is written capital F also. Anyway, function of A, B, C is equal to what are the values here? 0 and 2. Decimal numbers 0 and 2. It's a product of sums. Product of sums. So we write here pi. We write here pi. In the case of SOP, we have written as summation because sum of products. Here we will write pi. And there it was min terms and here it is capital M which represent to max terms. Max terms. What are the max terms for this particular expression? Expression nothing but 0 and 2. Corresponding to 0 and 2. A plus B plus C is one max term. A plus B bar plus C is other max term for POS function. So today we have seen the two standard forms. One is SOP and other one is POS. In SOP, the function's output will be 1 and in POS, the function's output will be 0. SOP, in terms of function we are writing, we will use summation and min terms model. In the case of POS, we will be using product in indicating that it is pi and we will be writing capital M which means max terms. So this is how we have to represent the two standard forms and its truth table. Thank you.